The t-test is used in a wide range of research designs. Here I'm going to present the three most popular designs in which the t-test is used in psychology. So we need to have one independent variable and one dependent variable. The independent variable has to be categorical, or also called nominal, with two possible values only. And the dependent variable is a numerical variable. So the first type is the type that we use in what is sometimes called randomized control trials or experiments. In experiments, we've got the independent variable has two values, control and experimental. It happens when we assign a group of participants to a control group and another group of participants to an experimental group. The control group will do something either passive or active, but is something that we are not interested in the performance of that group per se. The experimental group is the one we are interested in. We want to know whether a therapy works. So we assigned a randomly assigned participants to that experimental group. And then we compare the two groups in a numerical variable. So the dependent variable is numeric. We want to know whether the experimental group performs better than the control group, or that the values in the experimental group are higher than those on the control group. Or if it is something bad, like depression, we want to see whether in the experimental group those values are lower than those in the control group. Why do we use a control group? Why don't we just use the experimental group? Well, because the value or the mean statistic that we are going to calculate in the experimental group, we don't know if it is low or high. We need to compare that value to that in a group that was exposed to similar conditions to the experimental group, except the aspect that we are interested in. This is the method of differences. The second type of design in which the t-test is typically applied is a design in which there are two groups, group A and group B, and those groups were self-selected. This is a technical word to say that the values of that independent variable, group A and group B, were determined before the experiment. For example, we want to compare adults versus children. So these are the two values in the independent variable. We want to compare them in their working memory capacity, which is the dependent variable. So we cannot randomly assign participants to be children or to be adults. They are already what they are. Another example is gender. We cannot assign people to gender. People have a gender and we want to see the difference in some numerical variable. Or the country in which people are born. We cannot assign that people to those values. They have those values. To which culture the people are belong to. Again, we cannot allocate people to these two groups. What's the difference between these two designs? Well, in terms of the t-test, nothing. The statistics belong to the probability demon realm. So the analysis, the statistical analysis, will be exactly the same. We treat the two groups the same, whether they were randomly allocated, the participants were randomly allocated to them or not. The difference resides on assigning causality to the results. If we find a difference between group A and B, we don't know whether the difference is caused by the differences in this aspect of these two groups or because of something else. So we cannot establish that there is a causal relationship between existing into this independent variable, which is the gender, culture, age group, etc., and the dependent variable. We cannot establish a causal relationship. But for the statistical analysis, we are going to use the t-test, and if we do, we calculate a p-value, and that's all. There is no difference. I want to show you a third type of design, which is similar to the first one. So in here, we've got condition A and condition B. What's the difference? Well, we've got a group that we assign to condition A and a group we assign to condition B. Now, there is no control and experimental. We may be interested in just the difference between these two conditions. This is similar to the barley example. We want to know whether type A is different than type B, but we don't know, we don't have a control group per se. We're interested in both. So that's one difference. Now, condition A and condition B also can be randomly allocated. We allocate participants to those two conditions, or sometimes we cannot do that, allocate that randomly, and for example, we want to test a training method in one class of students and the other test method in another class. And so instead of assigning the participants to these conditions randomly, those groups already existed, and because of convenience of not being able to randomly assign people to classes, the classes were already there, and we don't have any other way of doing the experiment or the study, then we use that which is non-experimental, sometimes called pseudo-experimental, because we don't do random allocation of participants to the conditions.